we are going to discuss Leetcode question number 41, where we have to find the first missing positive integer. By positive, I mean that the integer should be greater than 0. And so we can check out these examples. So here I have a array of numbers and 1, 2 and 0. So the first missing positive integer here is 3. Similarly here 1, 2, 3 and 4 should have been there, but 2 is the missing positive integer. I'll discuss one more example where I have these numbers 7, 8, 9, 10 and 11 in the array, and the output in this case would be 1, because 1 is the first missing positive integer. Now that you have understood the question, this looks like an easy solve, that you can sort the array and then you can maybe like after sorting, I believe it's a cake, it should be a cakewalk. But here we have restrictions, that the time complexity should be big O n and space complexity should be big O 1. Okay, so so even the best sorting algorithm can give us a time complexity of n log n, like maybe merge sort or quick sort can give me a time complexity of n log n. But I would want a time complexity of big O n. Now here is the catch. So what we'll do is that we have the array anyways. So I'll just dry run this example. We have the array of numbers. So I'll first check that the number, and I'll just call the length of this as n. So I'll first check the number is between 1 and n. That is my first condition. Okay, and my second condition is that the number is not in the right position. So so I'm here, I'll just check if the number is not in the right position. But what do I mean by right position or correct index? That each of this number should be at value minus 1 index. So 3 should be at index 2, that is value minus 1. 4 should be at index 3, which again is value minus 1. 1 should be at index 0, that is also value minus 1. So this is what I need to check, and if it's not the case, I will just swap both of those two values. So like the current index of the number and the correct index. So I know it could be a little bit confusing, but I'll write the second condition, that the number is not at the correct index. Number not at the correct index. So I'll go to every index and I'll just keep swapping until and unless these conditions satisfy. So okay, let me start. So first I'll have a for loop. So let me call the index as I. So for I will go from 0 to n minus 1. Okay, and I will have to check both of those two conditions. Okay, I'll also write down the indices. So these are the things that I need to take care of. The value. So at 0th index, the value is going to be 3, correct? And value at index minus 1, sorry, not index minus 1, value at index value minus 1. So that is correct index. So value at value minus 1, as in this. So what is value minus 1? Value minus 1 should be 2. This should be 2. Now what is the value at 2? It's 1. So 3 should be, so this value, this number should be at this position. This number should be at this position. Now I have understood that value at, so the correct index becomes 2, and correct index is 2, current index is 0. So I will swap both of these. Now what will this look like? It will look like 1, 4, 3, minus 1. Now okay, I'll just keep doing this until and unless uh, any of these conditions is not satisfied. Now again, the value at 0th index becomes 1, okay, and 1 is equal to 1. So the number should be between 1 and n, both inclusive. So the number should be between 1 and n. This is my value. So value should be between 1 and n. Okay, now value here is equal to 1 after swapping. So after swapping it's equal to 1, and the second condition, the value is, I'll have to check if it is at the correct index or not. So the value is 1, correct index is value minus 1, so 0. So is it at the correct index? Is 1 at the 0th index? Yes. So it's at the correct index after swapping. So I'll come out of this I will go, I'll increment the value of I. So I will now become 1. Now 1, I is now 1. So value at first index is 4. So value at first index is 4. Now what should be the correct index for 4? It should be value minus 1. So correct index should be value minus 1, which is 3. What is the current index? Current index is 1. And what is the value at the correct index? Correct index, the value is minus 1. Correct? So we will swap both of these values. So what I'll get? I'll get 1, minus 1, 3, and 4. Okay? So this is my array. Now when I look at, when again, so I'll again check this condition after swapping. So minus 1 is my number. Minus 1 again is, the value is less than 1. So I'll just come out of this loop. I'll then go to I equal to 2. Now I equal to 2, I'll check if the value, what is the value at I equal to 2? It's 3. So 3 is at the correct index, correct? The correct index for 3 is 2. So it is at the correct index. So this condition won't satisfy that. The number is not at the correct index. So I'll skip, I'll go increment I again. Now I becomes 3. Value at 3 is 4. Now 4 is at the correct index because the value is 4, correct index is 3. Now it is at the correct index. So this condition won't be satisfied. So again we will come out of the loop. So these should be enclosed under a while, both of these conditions. Okay, so I hope you have understood this. So this would remain as my final configuration: 1, minus 1, 3, and 4. Now what I'll do, I'll simply use a for loop again. This is a second, so there is one for loop, there is a while loop inside it, and then there is another for loop. Now you might be thinking, I'll get to that question that we have 2 nested loops. I'll get to there. So here I have a for loop where I'll just traverse this array and I'll check if the number is, if the value at index, so if I am at index I, so I will go from 0 to n. N is the length of the array. Okay, 0 to n minus 1. I will go from here to here. So what I'll check, what I have to check, if value at index I is equal to I plus 1. Now what is value at index 0? It is 1. At index 1, it is minus 1. So this is where I know that this is my first missing positive value. So what I'll return? I'll return index I plus 1. It should have been 2, right? But we don't have a 2. So it should be I plus, return I plus 1. So this would be my missing value. Okay, now getting back to the question, that this is a nested loop. A nested loop means big O n square. But that will not happen. If you dry run all the examples, you will only swap n times. So since you are swapping n times, the time complexity of this is going to be big O(n). So yeah, this is why that's why the time complexity of this is big O(n), and this again is big O(n). So the time complexity remains big O(n), the space complexity remains big O(1). So this is how I believe we can solve this question. Um, I felt that it was a medium level of difficulty just because of the restrictions. Otherwise, it's an easy solve. So, thanks for watching this video. And if you found this video helpful, please do not shy away from subscribing the channel and also liking the video.